Timeless concepts from Physics Helpline. In this video tutorial, we will discuss two multiple choice questions which require calculations. One is from photoelectric effect and the second one about magnetic field due to toroids. Along with this, we will discuss two more multiple choice questions which doesn't require any calculation. They are to be responded directly from the knowledge of the concepts involved. These questions correspond to the 12th class syllabus and these are taken from the same NEET exam of 2019. The purpose of this is to make the NEET aspirants aware that such questions are also included in the NEET exams. The questions are as follows. Question 1. This is a multiple choice question which requires calculations. We are given that the work function of a photosensitive material is 4.0 electron volts. We are required to find the longest wavelength of light that can cause photoemission from this substance. The options are given in the question. We are required to find the correct option. Now for the answer. For a photon of frequency nu, energy is given by E is equal to h nu, where h is the Planck's constant. Now putting nu is equal to c by lambda, where c is the velocity of light and lambda is the corresponding wavelength. Therefore, E becomes equal to hc by lambda. From this, we get lambda is equal to hc by E. The value of Planck's constant h is equal to 6.63 into 10 to the power minus 34 joules second. Velocity of light c is equal to 3 into 10 to the power 8 meters per second. And 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. It is given in the question that work function of the material is 4 electron volts. Therefore, the minimum energy of the photon should be equal to the work function. So we can write E is equal to W is equal to 4 electron volts, which is equal to, converting into joules, 1.6 into 10 to the power minus 19 multiplied by 4 gives us 6.4 into 10 to the power minus 19 joules. Now we'll put all these values in equation 1, which gives lambda is equal to, the value of h is 6.63 into 10 to the power minus 34 multiplied by c is equal to 3 into 10 to the power 8 divided by E is equal to 6.4 into 10 to the power minus 19. Now we'll assemble the powers of 10 separately. Therefore we get 6.63 multiplied by 3 divided by 6.4 into 10 to the power minus 34 into 10 to the power 8 divided by 10 to the power minus 19 simplifies to 10 to the power minus 7 meters. These on simplification gives us 3.10 into 10 to the power minus 7 meters, which we can write as 310 into 10 to the power minus 9 meters, because the answers are in nanometers. Therefore, we need to express the wavelength in nanometers, which is equal to 10 to the power minus 9 meters. From this we get lambda is equal to 310 nanometers, which is the answer to question 1. Therefore, the correct option is A. Now for question 2, which is also a multiple choice question about two toroids 1 and 2. The total number of turns of toroid 1 is equal to 200 and that of the toroid 2 is equal to 100. The average radius of the first toroid is 40 centimeters and that of the second one is 20 centimeters. Both the toroids carry the same current I. We are required to find the ratio of the magnetic fields produced by these toroids along the two loops corresponding to the average radius. The options are given in the question. We are required to find the correct option. Now for the answer. The toroid is shown in the figure. The average radius is R, number of turns is equal to N, and let it carry a current I. Therefore, the magnetic field produced along this loop corresponding to average radius is given by B is equal to mu 0 Ni divided by 2 pi R. Therefore, for the first toroid, let the number of turns represented by N1 and average radius by R1. Therefore, the magnetic field along this loop is given by B1 is equal to mu 0 N1I divided by 2 pi R1. Similarly, for the second toroid, we can write B2 is equal to mu 0 N2I divided by 2 pi R2. We are required to find the ratio B1 by B2. So putting the value of B1 mu 0 N1I divided by 2 pi R1 into 1 by B2. 1 by B2 is 2 pi R2 divided by mu 0 N2I. That is what we have put here. Now we can see that mu 0 and mu 0 gets cancelled, I and I gets cancelled. Similarly 2 pi and 2 pi gets cancelled. And we get B1 by B2 is equal to N1 divided by N2 multiplied by R2 divided by R1. Now we'll put the values. The given values are stated here. N1 is equal to 200, N2 is equal to 100, R1 is equal to 40 centimeters and R2 is equal to 20 centimeters. Putting these values, we get B1 by B2 is equal to 200 by 100 into 20 by 40, which simplifies to 1. Therefore, we get B1 by B2 is equal to 1. Therefore, we can write B1 is to B2 is equal to 1 is to 1, which is the answer to question 2. Therefore, the correct option is B. Now, for question 3. This is a multiple choice question which does not require any calculations. We are required to establish relations between the three elements of Earth's magnetic field. Those are horizontal component H, vertical component V, and dip delta. The total magnetic field of Earth is given as BE. The options are given in the question. We are required to find the correct option. Now for the answer. It is shown in the figure. Earth's total magnetic field BE is like this, which makes an angle delta with the horizontal direction at that point. Therefore, the horizontal component H will be along this and the vertical component will be along this. And the angle of dip delta is shown here. If this one is V, then this one is also V. So therefore, let us consider this right angle triangle, in which V divided by BE is equal to sine delta. Therefore, V is equal to BE sine delta. That is what we have put here. Similarly, H divided by BE is equal to cos delta, which gives H is equal to BE cos delta, which are the answers to question 3. Therefore, the correct option is C. Now, for question 4. This is a multiple choice question and this also doesn't require any calculations. The variation of EMF with time for 4 types of generators are shown in the figures. We are required to find which one or more of them represent AC. The options are given in the question. We are required to find the correct option. Now for the answer. Now we know that a current which changes direction periodically is known as AC. We observe that in all the graphs, the current changes direction periodically in A, P and Q and R and S, all of them. Therefore, all the graphs represent AC. This is the answer to question 4. Therefore, the correct option is C. This completes the answers to all the questions of this video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.